Hey you guys, in this video we are going to be talking about electron configuration and hopefully clarifying what we mean when we're talking about electron shells and orbitals and subshells and all of that. But to start with, I do want to go back to where we left off in the previous video that maybe you watched about the history of our different kinds of atomic models. So hopefully you'll remember that after J.J. Thomson and his plum pudding model, once we'd moved on and discovered that an atom has a region in the middle that is that contains all of the positive charge for that atom and also contains the vast majority of the mass, we thought of electrons as being these tiny little balls that sort of were in orbit around the nucleus, the same way that a planet orbits its sun. So maybe this electron is in this trajectory around the nucleus like this, and we have maybe another electron that has a different trajectory where it's orbiting the nucleus like this. And I told you in that video that this conception of atoms circling around the nucleus is not what we think of as being accurate anymore. So I said that instead, what we now think of is we still have this region that's small and dense and has all of the positive charge for an atom, but that instead of electrons circling around it in orbits, we have what we called an electron cloud. So we said that there was an electron cloud simply represents a region of probability where we think we're more likely to find an electron. So in this red area, we're saying that for the electrons that exist in this atom, we're most likely to find them somewhere inside of this red cloud. So maybe it's here, maybe the electron's going to be here, here. It could be outside of the cloud, like here or here, but most likely we're going to find the electrons for this atom somewhere inside of this electron cloud. So that's what we're going to be talking about in this video, how this idea of an electron cloud relates to these words that we've been talking about. So we have shells. Oops. We have electron shells. We have subshells. And we have orbitals. So as you're thinking about these words, just to organize them in your head, maybe think about the fact that as you're watching this video, you are in multiple different places all at once. And so let's imagine, I'm not sure exactly where you live, but let's imagine you live in Seattle. That's at least where I am making this video. So I'm in Seattle. Simultaneously, I am in King County. And simultaneously, I'm also in Washington State, right? I'm in all of those places all at once. And in the same way, an electron is going to be within an orbital, a subshell, and a shell all at once because they have a hierarchical relationship like that. So shells are the biggest level, and they contain subshells. And then in turn, subshells contain orbitals. So in our analogy, we could think of shells as being sort of like the state, subshells being sort of like the county, and orbitals being sort of like the city. So orbitals are the smallest level of organization, and they fit within subshells, which fit within shells. And so when we're thinking about these different pieces of terminology, it almost feels to me, when I think about it, like a video game. So if you've played video games at all, a lot of times as you move forward in the video game, as you progress, you unlock new levels or you unlock new areas to explore. And in the same way, this is sort of how this idea of shells and subshells and orbitals work. So shells are the biggest pieces that we're going to be thinking about. So the shells are organized by numbers. So there's going to be a shell number 1, a shell number 2, a shell number 3, a shell number 4, and so on and so forth. So shells are really energy levels. And I'll get more into what I mean by that in a second. But for now, let's just say that shells are related to the distance that an electron is from the nucleus. But we'll just say shells come in levels. And so first we would deal with the first shell, then we would deal with the second shell, then we would deal with the third shell, in the same way that in a game you would deal with level 1 first, and then you would progress to level 2, and then you would progress to level 3, and so on and so forth. You go through the levels in order. And oftentimes when you are playing a game or a video game, you are able to access new abilities or new features or use new items or something as you progress in the game. So maybe once you reach level 2, you have a new area to explore, but maybe you also have like a new type of weapon you can use or something like that. So in the same way, as you move up in terms of what shell you're in, you get access to new subshells. And so subshells are specific shapes where electrons can exist in. And this all makes more sense in a little bit, but I'm just going to say subshells are different shapes, and there are different kinds of subshells, and instead of giving them numbers, we give them letters. And those letters are S, P, D, and F. So where those letters came from is kind of like beyond the scope of what we're going to talk about, and we don't really care how they came to be. They stand for things like S is for simple and P is for principal, but that's not why we care about them. We just have to kind of accept that instead of using A, B, C, D, they're using S, P, D, and F. So I said that as you go up in level, as you go up in shell, you get access to new subshells. So this is the order that we get access to them. So S is sort of like the basic subshell, and you start off, that's like your default. You get access to that automatically. So every level, 1, 2, 3, 4, and 5, is going to have access to this S subshell. That's kind of like when you start a game, you have like something that you get to use right from the very beginning. And then the next subshell is P. And you don't get this right away. You only unlock the P subshell once you get to level 2. So once you get to level 2, you get to start using the P subshell, and then you get to use it in every level after that. And then the next subshell after P is D. So you don't get level D, or you don't get subshell D until you get to level 3. Once you hit level 3, that unlocks the D subshell. So you get D after you hit level 3, and then the F, you get access to that at level 4. So you can see that at each shell, at each energy level, you get access to a new subshell. So you start off on level 1 or shell number 1 with just an S subshell. At level 2 or shell 2, you have that S subshell still, but you also have a P subshell now. And then at shell 3 or energy level 3, you have that S subshell, you have a P subshell, and you have a D subshell. And what I want you guys to think about these subshells as they're basically organizational structures, they're organizational shapes that hold within them orbitals, like we said. So subshells contain orbitals the same way that a county contains cities. So each orbital, you can think of it like a shelf or a box where electrons are going to be living, like the places that electrons actually are being held. And each orbital can only hold 2 electrons. So it doesn't matter if it's an orbital in the first level, in the third level, in the fifth level. It doesn't matter if that orbital is in the P subshell or the F subshell or the S subshell. Each singular orbital only can hold up to 2 electrons. That's its max capacity. Okay, so let's think about what this is going to look like in an example. So I'm going to draw our nucleus here. So maybe we should have an example to make this a little bit easier to think about. So let's think about helium. helium, if we looked it up on the periodic table, it has an atomic number of 2, which means it has 2 protons, and also, if it's neutral, 2 electrons. So when we're starting out, we have to start at the beginning. The same way you start at the beginning of the game, you have to start at the beginning of electron configuration. And the beginning is this first energy level, this first shell. So our where we start is always going to be 1s. So 1s, we're in the first energy level, and we're in the S subshell. And what that means is we have an electron cloud that's going to look like this. So S subshells are spherical. That's just like a property that they have. It's a shape. So S subshells, where should I draw this? Maybe down here. S subshells are spherical. If I was better at drawing, I could do it 3D, but you'll just have to take this round ball with some terrible shading as being spherical. So in red here, or pink, what we're showing is that we've made our first shell. And in that shell, the only thing that we have available to us is the S subshell, which is a spherical shape. And so in that spherical shape, we can fit our 2 electrons that helium has. So we would write this as 1s2, because we're in the first level, the first shell, we're in the S subshell, and we fit 2 electrons into that orbital. So that's an easy example for helium. But what happens if we want to fit more electrons? How are we going to do that in terms of where these electrons are going to fit? So to talk about that, let's look at the atom or the element beryllium. Beryllium has an atomic number of 4, which means that it has 4 electrons. So when we're thinking about beryllium, we still have our positively charged, dense, heavy nucleus. And in the same way that we did with helium, we can fit 2 of its electrons in this first 1s orbital. So we fit 2 electrons there, and we're in the first shell, the first energy level. We have that spherical S-shaped subshell, which has an orbital that's containing 2 electrons. But remember, I said that each orbital only fits 2 electrons. And in this S-shaped orbital, we've already put 2. So we're out of space here. So since we need to fit 2 more electrons into our atom, we're going to have to go up to the next energy level, the second shell. And the second shell is going to be farther away from the nucleus. So it's going to be a bigger sphere than what we had before. And this bigger sphere, these electrons are going to have higher energy in the same way that a ball on top of a hill has more potential energy than a ball on the ground. So I think you probably all know that gravity wants objects to be on the Earth's surface. So if you're thinking about how much potential energy an object has, the farther away from Earth's surface it is, the more energy it has, because it has the potential to want to fall down, right? And electrons, we know, are negatively charged, and they're attracted to the positive charge inside the nucleus. So electrons want to be close to that nucleus, the same way that gravity wants objects to be down on the Earth's surface. So in the same way that the potential energy for an object is higher as you lift it off the ground, the potential energy for an electron is higher as you move it further and further away from the nucleus. So these higher and higher energy levels, the bigger an energy level is, or the larger the number is, that shell is getting bigger because the electrons are moving farther from the nucleus itself. So we're occupying more and more space. We're getting farther and farther away from the nucleus. So like I said, the S subshell is the first thing that we can unlock. So we put 2 of our electrons in that 1s subshell. And now that we're in level 2, we know how to do this S subshell. We can like knock that out real quick. And so we're in the second subshell and we can fit 2 more electrons into this 2s subshell. And so what we have now is our 4 electrons all taken care of. 2 of them in the 1s subshell and 2 of them in the 2s subshell. So beryllium, we can say, has electrons. 2 of them are in the 1s subshell and the other 2 are in the 2s subshell. Okay, and I'm going to do one more example and then I'll leave this video at that because it's already getting a little bit long. So I'm going to have us think about nitrogen. So nitrogen has an atomic number of 7, which means it has 7 protons, and if it's neutral, it also has 7 electrons. So let's think about how this is going to work with our models that we have here. So same way, we've got our positively charged nucleus. We can fit those first 2 electrons in the 1s orbital, and then that one runs out of space, so we move to the next level, and we can fit 2 more in the 2s orbital. So we're up to 4 electrons if we're sort of keeping and accounting. But we said nitrogen has 7 electrons, so we still have 3 more that we have to find space for. And so you might think that we're going to go even further out into this third shell. But remember, I said that for each new level, you unlock a new kind of subshell. So in the second level, in addition to our S subshell, we also have access to a P subshell. And P subshells are just a different shape than an S subshell, but the idea is still that it's an area that an electron can occupy. So for our P subshells, let's see, I'm going to use a different color. If my pen will cooperate. So for a P subshell, they're basically sort of, people describe them like a dumbbell, but I think they actually almost look more like a peanut, which helps because then you can think of P as standing for peanut, the same way S stands for sphere. So they kind of look like this. Instead of those spheres, they're like a pinched off, they have these lobes and it's like pinched off in the middle. And the cool thing about the P orbitals is that there are 3 of them. For the S orbital, there's just 1 sphere, but for the P orbital, we have 3 different versions. So the one that I just drew is sort of along the x-axis, it's horizontal, but we also have a vertical P orbital. So this one would be like along the y-axis. And then finally, we have, if you imagine this same shape, but one side would be coming towards you from your computer screen, and one would be extending beyond, like behind your computer screen from the back. So like along the z-plane. So imagine if this orbital is coming at you from your computer screen, and this one was extending behind the back of your computer screen. So the P orbital is this dumbbell or peanut shape, and there are 3 of them. So there's that one, and then this one is the one that's like coming towards you and extending beyond the back of the computer. So the S orbital, there's only 1 of them, but the P orbital, there are 3. 1, 2, 3. And we said that for each orbital, we can hold 2 electrons. So if this is feeling confusing to you, one way that I've thought about it is sort of like a bookshelf. So you can think of the S subshell as being sort of like a small bookshelf that only has 1 shelf. And each shelf is the orbital. So each orbital is going to hold 2 electrons. And the S orbital, there's just 1 shelf, 1 orbital. So we can hold 2 electrons in the S orbital. But the P subshell is like a slightly bigger bookshelf that instead of only holding 1 shelf, it's got 3 shelves. because it's got these three different orientations for what those orbitals can look like. So the p subshell has three shelves or three orbitals, but still each orbital or each shelf is only going to be able to hold 2 electrons. So in total, the p subshell can hold 1, 2, 3, 4, 5, 6 electrons, whereas every s orbital is only going to be able to hold 2. And the same thing is going to hold true when we get to d and f orbitals. We're going to add even more shelves. So let's just focus on the s and p for right now, though. Okay, so we had in the first shell, this pinkish sphere, we were putting 2 electrons on that shelf or in that orbital. So we had the 2 electrons. Then we filled up that s orbital with the 2 electrons on that one shelf. So we had to move to the next shell, the second shell. And so first we did the s orbital. So that's in the blue, and we put our 2 electrons in the 2s orbital. But we said we had 3 electrons left over because we have 7 total. So instead of moving to the third shell, we're going to start using our newfound p orbitals. And there are 3 different ones. So we can put 1 electron in this horizontal lobe, this x-axis lobe. We can put 1 electron in this vertical lobe, so up and down, and we can put 1 electron in this z-axis lobe, the one that's coming towards you or going to behind you. And this has to do with this rule that as soon as you start getting more and more shelves, we're going to put 1 electron on each shelf by itself before we start pairing them up. So since we have these 3 shapes where they can be, we're going to put 1 electron in each before we start doubling up on electrons. Yes. So we've got shells that are represented by numbers, subshells that are represented by these letters, S, P, D, and F, and each different subshell can hold a different number of orbitals. And so we talked about in this video the s orbital, which just holds 1, or the s subshell, which just holds 1 orbital. So the s orbital and the s subshell are kind of the same thing. But once we get to the p subshell, there are 3 different orbitals in that. So we can have 1 orbital here in the p subshell, 1 orbital here in the p subshell, and 1 orbital here in the p subshell. And so this allows us to start filling up our electron cloud in different ways, depending on how many electrons we need to make space for.